Today we will be looking at disjoint events. And so up in blue, right next to the word disjoint events, I gave the definition, which is events that cannot occur in the same trial of an experiment. Well, that's kind of difficult to understand, a lot of tough vocabulary there. So let's take a look at an example before we get to the problems. So if I took the word math and I wrote those letters down on some cards, M, A, T, and H. So I wrote them on each on an index card, and then I went ahead and shuffled the deck. So I'll take these cards and I'll show that they're cards, separate cards. So I have these different cards and I shuffle them around, and I go ahead and try to select. So I shuffled the deck and I select a M or a T. And the key word is or. And so what I have here, two different events that can occur, M or T. Now, since neither one is the same letter, that means this is a disjoint event. So we can write this down. This is a disjoint event. Now, if you look at the word disjoint, dis means not joint. They're not together. So they're not the same thing. So a disjoint event because, we'll just say, because they cannot occur at the same time. I can't get both an M and a T at the same time because I've cut out these letters. I'm only choosing one. I select an M or a T. So I only select one of these, and I can't get an M or a T on the same card because I wrote them on different cards. That's a disjoint event. Now, let me give you another instance. Okay, so that's a disjoint event. Let's take a look at this one. Let's say I select a consonant. So a consonant, something that's not a vowel, any letter that's not A, E, I, O, or U, or sometimes Y. So any of those letters, I select the consonant or an M. Well, this is not a disjoint. Not a disjoint, because again, disjoint means they're not together. Well, these two things are together. A consonant is M. M is a consonant. And so it's not disjoint because they occur together. So basically, M is a consonant. So they can't be the same thing. And we'll see that in these next few examples that we have here. So let's take a look at this one here. Choosing a prime number or an even number from among the numbers 1 through 10. Well, even numbers are, let's go ahead and just write down some numbers here. We got 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Even numbers are ones that 2 goes into. So here's an even number. Well, that is prime. I'm sorry, that's not prime. That is not prime because we have 2 goes into it and 5 goes into it. So we call that a composite number. 8, well, that's not prime either because it has factors other than 1 in itself. It also has 2 and 4. 6, that's another even number, and that has factors of 2 and 3. 4, that has factors of 2 and 1 and 4 itself. Well, 2, right here, this is an even number, but it's also prime. So we would say this is not disjoint. They are together. And so disjoint means they're not together. They cannot be the same thing. Well, here, this is not disjoint, and the reason is because 2 is both prime, and prime means that it only has factors of 1 in itself. So, for instance, 1 is not prime because 1 only has the factor of 1. Itself is 1, so that's not prime. It has to have 2 factors, 1 and the number itself. So 2 is both prime and even. And we cannot have a disjoint event that the two things can occur at the same time. The two events can occur at the same time. They can't both be the same thing. And so this is not disjoint because 2 is both prime and even. Well, choosing a reptile or a zebra. So basically you're trying to see, is a zebra a reptile? If it is, then it's not disjoint. If it is not, if they're not the same thing, then it is disjoint. So we would say this is disjoint because they're not the same thing. And the reason, I would just say, is that a zebra is not a reptile. And so that would explain that to me, because we can't, so let's go ahead and fix the spelling here, can't have a zebra being a reptile. If it was, then it would not be disjoint. See, disjoint is when the things are not together. They're not the same thing. A zebra is not a reptile, and a reptile is not a zebra. So those are disjoint events. And so you can't choose both an animal. You cannot choose an animal that is both reptile and zebra. And so that's why it would be that way. And so move on to the next type of problem that we'll see. We're going to use this concept of disjoint events to help us with the probability. So with disjoint events, since they're not the same thing, zebra is not a reptile, what we can do is if we find the probability of 1 and we add it to the other probability, we'll get the total probability. And do you always have disjoint statements when they use this word or? So when you see the word or, typically we're talking about a disjoint event as long as it has that idea in common where the two things are not the same. So rolling a prime number. So let's go with probability of a prime. So probability of a prime, and we're talking about a number cube here. So rolling a prime number or a 1 on a number cube. So our different options are a 1, 2, 3, 4, 5, or 6. So if we look at a prime number, our prime numbers, well, 1 is not prime. So our first prime number is 2, then 3, and then 5. That's it. 4 and 6 are not prime. 1 is not prime either. So it's 3 out of 6. Well, if it's a disjoint event, we'll be able to add them together. So what's the next one? Probability of a 1, of rolling a 1 on a number cube. So probability of a 1. And so remember, 1 is not prime, so we can do this. This is a disjoint event, so we can add the probabilities together. And so 1 out of 6, we add those together, we get 4 out of 6. So again, it's real important to understand that it's only a disjoint event when the two items are not the same. They're not the same thing. Like, for instance, the zebra is not a reptile, or an alligator is not a mammal. And so we've got two different things there. So we have to make sure that we have disjoint events before we try to add the probabilities together. So once we do add them together, though, we can reduce the fraction and take out that common factor of 2, and we're left with 2 over 3, and that would be our answer. So 2/3 of the time, we're either going to roll a prime number or a 1. Choose a number less than 5, or a number greater than 16 from the cards from 1 through 20. So the ones that are less than 5 would either be 1, 2, 3, or 4. Okay, so that's the probability of less than 5. We would say it would be 4 out of how many are there? 20 is the total. So this is our total. So that's why I'm using 20 on the bottom of the fraction. Now, I can add them together as long as the two are not the same. We don't have any numbers over here that would also be less than 5. So let's read what it says. We want numbers that are greater than 16. So greater than 16. So again, the key is they cannot be the same. They have to be disjoint to use this. So greater than 16, well, it can't use 16 because 16 is not greater than 16. So 17, 18, 19, and 20. Again, that's only 4. 4 out of 20. So we add that together, we get 8 out of 20, which reduces down to 2 over 5 when I go ahead and take out that common factor of 4. So 2/5 of the time, we're going to pick either a number less than 5 or greater than 16. choosing a consonant or an A. Well, okay, those are disjoint because a consonant is not an A. If they are the same, you cannot do this method that we're doing where we're adding these probabilities together. So the probability of a consonant. So consonant. Well, consonant is like the C, the L, so that's 2. 3 is the F. 4 is the R. 5 is the N. So we have 5 out of, let's count how many there are. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 letters in California. Well, since there's only a consonant and a vowel, and that's what they're asking for here. Well, actually, they're just asking for an A this time. We've got to count the number of A's together. So we've got 1, 2 A's. That's it. 2 out of 10. And so we add those together. 7 out of 10 is the probability of either selecting a consonant or an A from the word California. Well, the next one, similar, they're asking for the probability of a consonant again. So we know consonant is not a vowel, and that's the other item they want. So we know those are disjoint events. So 5 out of 10. Well, if there's 5 consonants, that must mean there's 5 vowels. Has to be, or else, because there's no other type of letter other than a vowel or a consonant anyhow. So we have 5 over 10. And so those would end up adding to 10 over 10, which just makes 1. It's a certain event. We're either going to pick a consonant or a vowel, definitely, one of those two. And so that is a certain event. Well, those are the types of problems you'll see on the first part of the homework. Part 2 has the second part.